This is a video about how to compare the cross-validation of a model that you develop with multiple regression using SPSS and comparing it to a holdout sample. This process of using a holdout sample is sometimes called cross-validation, and it is also called out-of-sample validation or out-of-sample testing. So I have already randomly split this data set into two parts. I've used a filter variable with randomly sampled halves. So what we're going to do is we're going to go to analyze, and we're going to run an initial regression on those where the filter is 0. So we go to regression, linear, and our dependent variable in this case will be standardized science scores. We're going to try to predict standardized science scores from standardized math scores, standardized reading scores, the gender of the individual, which is dichotomous 1 or 2, and the school type. I'm going to leave school type out. So we're just going to use these 3 predictors now for this purpose. We are going to make sure that we run all of our usual statistics. So for our primary purposes here, we're going to make sure that there's not a huge problem with multicollinearity. We would typically save the descriptives, but for our purposes, we're just going to go down here and ask for case-wise diagnostics, because we know that if there's a big residual within this data set, it might have an influence on our residuals that we're going to be generating and then squaring and finding the standard deviation for. So we're going to click continue. We're going to go over here to save, and we are going to click on asking to save the unstandardized predicted value and also these deleted residuals. So these are the residual values that are going to be saved that include the deleted cases, the cases that were not part of our initial program. We're going to click continue. We would typically ask for, under plots, we'd ask for our normal probability plot, but I'm not going to deal with that right now because I want to focus on the interpretation of the squared residuals and comparing them to the out-of-sample testing. So at this point, we're going to make sure we do our selection, and we're going to run our initial rule, our initial selection on those filter variables that are 0. Okay, so we're going to run it on this, and then we're going to check the cross-validation on those that are scored a 1. So we click continue, and click OK. SPSS will run this quickly, and part of what we're going to do is we are going to first of all look back at our data set to make sure that the new values have been added. So here's our predicted value, and here is our residual. Okay, so even when the filter was 1, which means that it was not part of our regression that we ran, our model that we generated, we still see that we end up with a predicted value for that as well as a residual for that. So this residual here, this 0.74, comes from comparing that science score that we had. So here's the science scores. Here's 39. The predicted value for this individual was 38.2. So that difference was about 3/4 of a score point. So that residual is very close. This next residual is not very close. So part of what we're going to be looking for as we look at our results is whether or not, when we look at our model, we're going to look to see whether or not we have any really extreme residuals that are outside of that 3 point. And we can see right here is that we do have at least one residual that is above 3. So we know that that wherever this case is, it might be exerting a lot of influence on our estimates of error around the residuals, because we're going to be squaring these residualized distances. So as we look at our model, what we see is the model that we use, the data that we use, accounted for about 56% of the variance. And it looks like when we square our prediction for our unselected group, it's going to be a little bit less than that, probably closer to 51 or 52%. So it looks like as we move from our selected group to our unselected group, we are losing some predictive ability. So we're moving from about 56 down to about 51 or 52. And I get that 52 by squaring that number. We see this standard error of estimate. This is telling us that the standard deviation of the residuals for this sample is about 6.5 points. So the residuals are distributed around so about 6.5 points of error, plus or minus, around that zero prediction is the amount of error that we're facing on the average. Okay, so what we're going to be doing is we're going to be generating an equivalent standard error of estimate for the unselected cases, and we're going to be comparing that computed value to this value, and we hope they are fairly close, right? Because if they're either significantly greater than that or significantly lower than that, we have some problem with the quality of our model. But if they're close to this, then our model is pretty equivalent for both the basically what we call the training sample and the validation sample. This is the training sample, this is the validation sample. So when we say out of sample testing, here is the sample, here is the out of sample. Okay, so this is a cross validation. So what we're going to do is we're going to try to generate an equivalent of this standard error of the estimate, which is the standard deviation of the residuals for this sample, and we're going to try to compute the equivalent of that for this sample. We can look at our model and we can see that all of our predictors are statistically significant at the 0.05 alpha level. So we are hoping that when we look at that for our independent set, we get the same basic conclusion, and that we are also within the same level of confidence with our out of level values. So we know again that it appears that there's only one value that is beyond 3. So part of what we might want to have to consider is, we're going to go ahead and run this as it is, but if for some reason we end up with a problem, we might want to consider deleting this case, because it seems that it could have a lot of impact on the fit of our comparison. Because what we are essentially doing is we are computing the standard deviation of these residuals, and this is a standardized residual that is telling us that it's more than 3 standard deviations away from the mean, and that will indicate then when we square that residual to get the standard deviation, to get the variance and the standard deviation of these residuals, it's going to have a lot of impact on our calculations. So we might want to be careful about that. So we're going to go back to our data here, and we have our residual here. What we want to do now is we want to compute the square of these residuals. Because we're wanting to get to the standard deviation of these squared residuals. So we want to square these residuals and get the standard deviation of them. So it's easiest for us to get the average of the squared, get the standard deviation, get the squared deviations first, and then calculate the average of those squared deviations, which will be the variance of the squared deviations, of these deviations, and then we can just calculate the square root of the variance of the squared deviations. So we're going to go to transform, compute. We're going to create a variable called squared residuals, and that's going to be a product. We're going to take the deleted residuals, and we're going to click on the asterisks twice followed by a 2, which means square this number. So this is going to give us the squared residuals. Click on OK. Go back to our data to make sure it worked. We now have squared residuals. 0.7 squared is going to be 0.55, so that worked. Now we just have to get the average of these squared residuals. The average of the squared residuals will be the variance of the residuals. We go to analyze, but again, we only want to do this on one set of our cases. So we're going to go back down here to select cases because we only want to run this on the cases that we did not include in our initial regression development. So we're going to say if the condition is satisfied, and the condition in this case is that the filter variable is 1. And click continue. Because that will allow us to only run this on the cases in which we are that we have not developed our initial regression equation on. Okay, so now we're going to go back to that data set. We have our squared residuals. We're going to go to analyze, and we're just going to get the descriptives for this. We just want the mean for these squared residuals. So the mean of these squared residuals is 43. To get the square root of that, you just take the square root of it. So the square root of 43 is about 6.5. So we can go back to our initial model, and we see that the initial standard error of the estimate was also about 6.5. Okay, so our validation results based on this mean right here is equivalent, or almost equivalent, to what we had with our initial training group. Okay, so that gives us evidence that the model that we used, that the regression equation that we generated here, seems to work quite well in terms of yielding an equivalent result or fairly stable result with an unselected group that came from the same basic population that we did with our others. So there are other ways, there's a number of other ways with SPSS to get to the variance and standard deviation of the residuals from the training sample and applying it to the validation sample, the out-of-sample testing. I just wanted to show one way of doing it so that you would see where all of the numbers were coming from. I hope that you find this helpful.